All right. So, welcome to episode 9 of Tech Laughs Bytes. And I'm just going to let you introduce yourself. So, could you tell us more about who you are, what you do, and pretty much how you got into the technology space?
Yeah, hey Castle. Yeah, so first of all, thanks for inviting me. Yeah, it's always a pleasure to share my story and to be in podcasts like this. So I'm Mark. I'm currently working as a staff data scientist at Meta. I used to work in many places like TikTok, startups, big corporations. So I will just skip this part. And
Okay.
on top of that, I'm LinkedIn influencer, so I'm sharing, I hope, insightful insights, some hints, for data scientists, data analysts, and everyone who is interested in data. So
Mhm.
yeah, don't forget to follow me on LinkedIn and on my newsletter. So about how I ended up here. Um, I would say so. First of all, it all started with my education. Say my education was rather technical, so
Mhm.
it was like focused on math and all of it. But
Mhm.
I mean, so I graduated like when uh 13 years ago. Oh my god, yeah,
Oh,
it's been a while. 12 years ago. Yeah, 12 years ago. So 12 years ago, even data science wasn't like on such hype. So like
mm,
nobody, knew about like, you know, the current state of it, I would say. So I also, didn't have any intention to go to this field because I didn't know about it. So I
okay.
started my path as Excel developer. So I just developed different insurance calculators for obviously insurance companies in Excel for
Okay.
internal use. And it's
Okay.
just because it's a job I could find. Uh, so there was some like kind of software development approaches, something
Uh,
related to data, and
uh,
yeah, I mean
uh,
whatever. I even remember like when they asked me about what salary do you want.
yeah.
I was like, I mean, I can work for free. I mean, like, I just need experience.
Oh,
And they're like,
wow.
no, yeah, I mean, like, no, sorry, we can't do it legally. So so you have to, earn, yeah. And I'm grateful for that even there. Yeah.
Definitely.
So after that, I got myself to the bank industry where I started to understand what like is IT in general overall, what is like
Mhm.
data analytics, product analytics, how we can do like how can we use data for you know uh, business decisions and how it can influence it. So what is like kind of statistical analysis, what models can be, etc., etc. And like
Mhm.
step by step, so I would say the data scientist profession was
Mhm.
created because I mean, 30 years ago
Yeah.
it was like I mean data something. So yeah, that's the so. But then yeah, there were like a lot of such roles, and yeah, so I just applied, started working there. So then I started working in some startups. Then I got uh, an offer from TikTok, moved to Ireland, and then finally I'm here like at Meta in London. Yeah, I mean I skipped a lot of steps. So if you're interested, like ask me
Yeah.
about around it. But yeah, it's about how I like ended up in I would say data domain.
Wow, awesome. And I think, just all of this, decades of experience that you've had with data, just thinking about it, just like from what you said, back in those days, there was not so much a lot about, the buzz about data scientists. But you see, over the
Yeah.
years, it has paid off. So that is really good.
Yes. Yeah.
Yeah.
Yeah. That's true. I mean, it's So I see so big difference. Like 13 years ago, I mean,
Mhm.
data science overall exists for 20, 30, 40 years. I mean, if we talk about like I know some statistical analysis as a part, so for
Mhm.
hundreds of years. But like as a profession, it's only started, I would say, um, uh, created like 12 years ago, 10 years ago, and even like at this years, it was like, yeah, we don't know what data scientists should do, but yeah, let's
Yeah.
hire someone, and they tell us what to do. So it was like this. Now it's like, yeah, we have like machine learning engineer, we have like product data scientist, marketing. I mean, a lot of like domains, specifics, nuances, all of it. But yeah, at that time, it was just data science.
I know, right? Awesome. I mean, just speaking about the revolution of data science and how data has improved businesses. So I wanted to talk about, why machine learning engineers love framework. I mean, there's no machine learning engineer that I meet and they always talk about frameworks. So do you think the reason why they love frameworks is because, probably for efficiency, or they just like it because it helps them to train the models without feeling like, they're trying to assemble an IKEA furniture without instructions, with instructions that were probably written in Greek? So why do ML engineers, why do they love frameworks so much?
It's a good question. I think it's just coming from technical background and like
Okay.
technical mind people. So we
Yeah.
like some framework where that we know how it works and we
Yes.
can just apply it and we can get an expected outcome, right?
Hmm.
So
Yeah.
why not use it? And everywhere, whenever it's possible, yeah, let's do it. Either it's like some software development, it's model development, it's I don't know,
Yeah.
just experimentation approach. It's just easier because you have some steps, you understand how it works, and you,
Absolutely.
uh, yeah, and I mean there is some expected outcome. Yeah, I mean it can be different, but you will get something. So yeah, that's and like this
Mhm.
frameworks are based on like practice and experience of many people. So
Yeah.
yeah, they kind of trustworthy. So why not use them? And I believe
Yeah.
it's not like for machine learning engineers, like for many professions and many people. But
Yeah.
that's my understanding, and that's why I love using different frameworks for different challenges.
Okay. Okay. Do you want to tell us some of the frameworks you love to use?
Uh, when it comes to, for example, data storing, storytelling, right?
Yeah.
So, I mean, there are a lot of frameworks, right, that you can use. I'm
Mhm.
trying to remember. I mean, I'm always like a bit, you um, challenging with all these acronyms and names. Uh,
Yeah.
but for
Because there's
example,
so
like
many of them.
yeah, I mean, so for example, star approach, right? So like most people know, like situation, task, action, result, right?
Yeah.
It's a bit outdated, right? But the
Yeah.
idea is, I would say, uh, pretty important and efficient.
Yeah.
Because, for example, in data storytelling,
Hmm.
so give two different people the same numbers, the same
Yeah.
data, etc.
Yeah.
It can be two completely different stories, right? And the outcome can be different. Like
Yeah.
in for one guy, and
Yeah.
there's going to be some decisions made for
Yeah.
business, and another one just stakeholders will tell you it's not very trustworthy. And this framework can help you to guide through all these challenges. Like, yeah,
Mhm.
ask me about like so tell them situation like we had some delay, some issues. So we had some tasks. So we've done it. and then we
Yeah.
have like some results and outcome,
Yeah.
and that just helps. So
Yeah.
yeah,
Absolutely. I mean, I totally agree with you when you say frameworks help, in terms of like the step by step and, sort of like just guides you, towards a result that you mentioned as well. Okay, that's
yeah.
really good.
Yeah, for me, framework also, I would say helps in terms of writing when I'm thinking. So when you're thinking, right, about everything, right, if you
Mhm.
don't write it down, don't jot it down, all right, you'll forget it like in any couple of hours sometimes.
Yeah,
So it's
yeah.
all. So for me, it's always like useful to write it down, like in whatever format it can be, and then
Mhm.
just you can come back, I don't know, 3 weeks after this. So
Yeah,
it's similar from this perspective. So framework give you some tool. So
yeah.
for example, the documentation that you can follow, and it can be useful for you, for your team, for product, for business, for everything.
Absolutely. And just like you mentioned, it's something that you can document and always reuse it again. So it's
Yeah,
very important. Yeah, that's good.
yeah. It's always framework, like think,
Yeah,
document, something like that. Yeah.
absolutely. Okay. So I know we all love a good EDA, and but seriously, when we do the whole explore the data sets, before modeling, it's because, because skipping EDA is like starting a road trip without checking the map and then blaming the model when you end up in an
Yeah.
overfitting. So pretty much, why do we do exploratory data analysis for data sets?
I would say the main idea of it is to bridge the gap
Mhm.
between business and model. So the biggest challenge for data scientists currently and for data related people is like they have some data. It can be
Okay.
like one data set, it can be a lot of tables, but they don't know what's inside it. Like, what does mean this exact value for
Okay.
category, right? Or even sometimes for region. Like,
Okay.
so I know it can be like EMEA, right? So, but what exactly it means in this case? I mean, there are a
Yeah.
lot of such cases. And if you don't understand it, even like your model proves something, but what it
Yeah.
actually means, like, so your model is very effective, and whatever metric you choose, and the accuracy is very high, and you see
Hmm.
that like best performance metric features is like a category, like retention, whatever. Then
Yeah.
the question is what it is, how you got
Hmm.
it, and how
Hmm.
you can use it in production. Because if you
Yes.
don't understand like what retention, how it measured, you can't use it like in production. You
Correct.
can explain, I mean, what your model is actually doing. And
Correct.
overall, for model developing, yeah, EDA is helping a lot. So it can even help you with some baselines, right? So you
Yeah.
just can notice, find out something that, I mean, not very obvious from like business perspective, from but data is just crying out
Yeah.
um, about it. So just use it. So I, I would say it's just the best approach to
Okay.
bridge this gap
Yeah.
and to actually deliver some something impactful. Yeah, because
As-
if your task is not about I would say get high score on Kaggle competitions, and even though like on Kaggle it's sometimes unsupported, but it depends on competition. It's important to have some domain knowledge. So if
mhm.
your goal is to deliver impact, so EDA is a must go. So it's a must step for you in the process.
Yeah. I totally agree with you when you say it's definitely a must, step in actually achieving the results you want to achieve with machine learning algorithms. So yeah, yeah, that's pretty good. Okay, so we are moving on to machine learning formulas. So we know that, all of this algorithms from regression to
Yeah.
by models to so many of them, all of the algorithms. There's so much, like, for to Eden Markov, probabilistic models, all of this. These are all built on formulas. So pretty much, is it like, they are maths with fancy clothes? But as someone with, of course, you've been in this profession for over 2 decades. So you're probably the best person to answer this question. Um, and of course, you've worked with, multiple industries. And so my question is, have you ever faced any challenging problem that you had to start running hypothesis tests with different algorithms to solve a problem just because, maybe your gut said, well, from this result that I got, I don't think this might be right. And so basically, for instance, you had a data set and you kind of like got a result, but you just had those instincts, like the machine learning engineer instincts. And you kind of like, you kind of felt like, I think I want to try another algorithm, or I want to, use something else. So could you walk us through how you would sort of like solve this challenge problem?
Yeah, I mean, so from this perspective, so every machine learning algorithm
Hmm.
has, first of all, like different assumptions that you need
Okay.
to check.
Okay.
And you will check them. I don't know, like variant stuff, like some parallel trends, whatever it can be. So there are a lot of them.
Okay. Yeah.
So the second thing, it's about like scalability. It's also very important factor that like, yeah, even though like I know that this model would perform better, but
Mm-hmm.
I wouldn't use it just because of scalability, and it
Okay.
won't work in production.
Okay.
So the third one is like kind of a nice approach is just to use different approaches, right? So different models just to see how it goes, right?
Okay.
What the results are you gonna have if you have resources, timing, all of that.
Okay.
Uh, but I wouldn't say that in like at least in a product
Mm-hmm.
world, this kind of problems happen very often
Okay.
because mostly it's about what problems you're solving, what goals you should achieve, what metrics you have to choose, where to get data, how to clean it. So what to
Mm-hmm.
do then, like how to implement it,
Yeah.
what like uh, what impact you will get, how to scale it, etc., etc. And like the the whole option, the whole like variety of machine learning models right now. I mean, it's it's not a big issue right now, right? So there is a set of some models that you should use as a
Mhm.
baseline because it's like easy, scalable. I don't know. Linear regression, for example, logistic regression for
Yeah.
classification purposes. And then you just add complexity, check assumptions, etc., etc. Yeah,
Okay.
sometimes you feel that something is wrong, but why it's wrong? Maybe
Okay.
it's just not working on this data. Yeah, so either change the data or change the model. So obviously, change the model because changing the model is a lot cheaper than changing the data. So yeah,
Okay.
and all of it like help you to guide you through to the right choice.
Okay. So you would do the different models. You try to like test the different models.
Yeah, yeah, and it's as you do like I mean in the real world, it depends like on the goal,
Okay.
obviously. So if you get some really impactful results with your baseline, yeah, why not like just apply it and that's it. So see
Yeah.
like how it like behaves in the real world and
Yeah.
so run some A/B tests, etc., etc. But
Yeah.
yeah, so during like offline computing, you just choosing amongst like the winners, and yeah, that's how you go.
Okay. Also, so when it comes to demand forecasting and prediction, a lot of times kind of like very similar. Like, machine learning engineers are always like, oh, well, well, it's sort of like almost very similar, but we both know that they are different in terms of, depending on what you want to do. So, how do you actually know which one to use for what? So, like, when do you say you are going to be using demand forecasting versus when do you say, oh, I'm going to be doing predictions? Because sometimes it kind of feels like, data scientists just pick whichever one sounds fancier in a meeting or something. So, when do you use which for which?
Yeah, so uh, it's a good question. So I mean, the whole difference is obviously like in the naming, right? So prediction is like I would say more broader term, right? And you can
Okay.
apply it to like everything. I don't know, you can predict stock prices, right?
Yeah. Yeah.
Whereas like, I mean, it's not demand forecasting.
Yeah.
Um, so demand forecasting, it's like what your like customer demand for an ice
Yeah.
cream, right? Any over winter, over
That's,
summer, I would say.
yeah.
So, like it's usually made for like kind of business planning and stuff.
Yeah.
Uh, I would say if you see that like you need to take into account like some I don't know, production data, inventory stuff, because a lot of demand forecasting is also based like on OPEX costs and on all of it. So whether it's like right now profitable or not. So
Yeah.
it's I would say demand forecasting is like part of prediction, but yeah,
And
not always. Yeah. So
yeah, no,
yeah, and like so prediction it can be about like everything
yeah,
in general. So I mean, you can predict whatever you want. Demand
absolutely.
forecasting, it's exactly in the context of like demand, data.
Yeah,
So you can use like some in terms of like models. All right. So some approaches like you can use just some um a regression like with prices, some time series model, causal models, etc., etc. So for prediction, you have, I guess, wider options. But the whole difference it's about in this small word demand, all right? So you just need to understand what it means for you specifically, like
yeah,
what's like um, profit in the case, what's like losses and all of it, and yeah, make a choice.
yeah, absolutely. I totally agree with you. When it comes to demand forecasting, it's always the business. It's always the how much am
Yeah,
I going to next 2, 3 months? And
yeah.
then of
So
course
because yeah,
everything.
prediction, it's like yeah, you can say not like everything, but yeah, most of it. But for
Yeah,
demand, you should be very specific. Like
yeah,
if I don't know if we are gonna purchase X inventory, then we can based on current demand level, we
yeah.
can sell Y ice creams, for example. So you should
Okay.
be very specific about like units, about the context, what you take into account, etc., etc.
Mm-hmm.
Yeah.
Okay. Awesome. Awesome. That's really great. So,
Mm.
move over to predictive analytics. It's just like, when you were talking about your intro initially, when you talked about how back in the days, we didn't have, so much about data science was kind of like, well, we're just, doing some really nice stuff with Excel and all that stuff. But
Yep.
now analytics has gone, businesses have seen the real value with predictive analytics. So, And of course, it's been around since the days of Fortran,
Yeah.
and some businesses were still, businesses still used it, somehow, and they survived with it. But of course, today things are way more modern, right? We have so many nicer ways of actually doing predictive analytics. So, my question is, if you were joining a company today, you know, how would you roll out a modern predictive analytics framework without accidentally time traveling back to the 1970s of using Fortran? So pretty much this company does not have a data science department, and you are just going to come in and you're going to say, okay, we're not going to be using Fortran. We are going to be using a much more modern approach. Of course, we're in 2025, and you know, this is what would yield profitability and great decision making, and of course, profit for the business. So, how would you roll out that for the department?
So yeah, first of all, like it depends on many factors. So
Okay.
even like Excel and Google Sheets
Yeah.
have developed a lot. I mean, like a week ago,
Okay.
I don't know why, but for the first time, I just tried like Google Sheets AI function, and I just based on this data, just plot me X, Y, Z. And like
Yeah.
everyone who works with like Google Sheets knows that sometimes plotting data is not like the most easy part of it. But I mean AI has completed it like
Mhm.
in like 10 seconds. Very good.
Mhm.
Like, oh,
Yeah.
that's awesome. Um, so I would definitely start with first of all like business current challenges in
Okay.
terms of like if we are profitable and we have like ROI like I don't know thousands of like percent. I
Mhm.
mean like we don't need it. Like I mean we are okay where we are, right? I'm not sure
Yeah.
what the industry is gonna be if we have like thousands of ROI without like data. But anyway, it's like um, one of the options.
Yeah.
So then like you should go to data itself. Do we have
Okay.
data? Do we have warehouses? Do we have
Mm.
like some up to date of it?
Mm-hmm.
So uh, do we have an understanding of like metrics hierarchies, data hierarchies? Like do we have like
Absolutely.
just our North Star metric? Like I don't know, should we
Yeah.
focus on growth right now? Should we focus on profitability? Should we
Mm.
focus on just revenue, and then we're gonna sell our company to some investors? I mean, there are
Yeah.
so many options, but you
Mm-hmm.
definitely need to check like data
Yeah.
in general and fix this if it needs fixing,
Yeah.
because what you want to ensure that you have your data up to date in the
Mm-hmm.
correct format and comprehensive, right? So that it covers the whole of your business.
Of your business.
So
Absolutely.
yeah, then like go to like business challenges. I mean,
Okay.
for example, I don't know, we have some problems right now with recommendations to our existing customers.
Mm-hmm.
Okay, yeah, uh, let's do like let's develop recommendation model, and
Mm-hmm.
there are different options here. We can
Okay.
just use I don't know, we can use like some Meta. We can use like maybe Google
Yeah.
models for that. No need to develop it from your own. If you have
Yeah.
something specific and you have resources, so you should think about like what resources do you have,
Mm-hmm.
what's gonna be stable and still existing in like
Yeah.
1, 2, 3 years,
Yeah.
and find a balance
Mm-hmm.
and apply it, right? So maybe in
Yeah.
your case, you don't have like a lot of resources from a data
Mm-hmm.
science perspective. Yeah,
Mm-hmm.
so just reach out and to Google, Meta, whatever providers that can give you recommendation models options, and
Yeah.
they can give you like API already. So you just should call. I mean, you can just call it,
Yes.
implement it in production, and you're good.
Mm-hmm.
So
Mm,
you're good to go. Because if we
yeah.
talk about like prediction analytics and building from the ground up data science in your company,
Mm-hmm.
so it's going to require like infrastructure, some legal stuff,
Mm-hmm.
so maintenance,
Mm-hmm.
so data scientists,
Yeah.
and a lot of other things. And yeah, so you can reach some levels of, I don't know, of performance as like big players, but I mean, you
Mm,
can do something bespoke to you. So it's always a chance. So if you like need to do something fast, something reliable, yeah, I would just use, and we have like some limitations in resources. Yeah, I would use like some cloud options, apply it, and etc. etc. And yeah, so it's based on like business department challenge,
yeah.
priority, etc., etc. So yeah, okay, we fix this recommendation part. Let's do, I don't know, some CRM analytics, right? So how
Yeah.
we segment our clients and how we like send them some offers.
Yeah.
Uh, so yeah, and then let's think about it. Okay, so there are some options, but maybe it's easy for us to develop from our own because we have some data. It's not like very difficult and very big rocket data science,
Yeah.
and we can experiment with it. We don't have to to implement it like in production on like for customers to use it like every second. So yeah, we just send the subscription, some newsletters, some offers like every week, whatever. So we can do
Mm,
it. And then let's explore like causal inference models where it exists, like
yeah.
Python or some other frameworks, whatever, whatever. And that's how I would say I go like in case by case. And overall, it's better to have some strategy. So it's always difficult to maintain, the whole zoo of tools, etc. So
Yeah.
it's also important to follow one kind of
Yeah.
flow in terms of tools.
Mm-hmm.
Yeah, but sometimes yeah, something can stand out.
Yeah. That is just awesome because obviously you've just literally built a data science department.
Thank you.
Honestly,
Yeah.
like from start to literally, to when you start, rolling it out with, newsletters to different departments, letting them know what's happening in your new department. So that's really, really great. Yeah, absolutely. I agree with most of the
Thank
strategy
you.
now that to build that. Well done. That's good. Um,
Thank you.
so my next question is, when it comes to hyperparameters, right? So, we know how super important hyperparameters is in machine learning, and it's supposed to make our models, better. But until when your model starts giving you 100% accuracy or 1.0 accuracy, then, the model has just memorized your data. And of
Yeah.
course, that is way much overfitting for that. And so, how do you decide your fine tuning strategy? So is it that you start small and maybe give, one of the parameters, maybe give it start small with a smaller value, or you go big with a bigger value? Or is there some kind of machine learning tricks that machine learning engineers, sort of like use nowadays? How would you avoid that overfitting and really really where the model just memorizes the data?
Yeah, I would say the most important factor here is your data set
Yeah.
and how you choose your training, validation,
Yeah.
test data sets to
Yeah.
try to avoid bias, try to avoid, sorry, overfitting and
Yeah.
all of it. So it's like priority number one.
Yeah.
Uh, so the second one, it's just kind of um, some limits because
Yeah.
if we don't So if we don't discuss like some LLM models and like some research and stuff
Yeah.
where they, I would say very competitive in terms of like performance metrics and how we get there. So
Okay.
you should have some understanding of like, okay, so if this model shows
Hmm.
me X
Yeah.
some performance, that's
Yeah.
okay, and I won't put another week of fine tuning into this. So I will just call it a day
Hmm.
and try to test it. So online testing in real production and all of it, and see how it works. So
Okay.
I would say these two things are very important in
Yeah.
terms of like fine tuning.
Okay.
In terms of like just like you know starting small, starting big, etc. I don't
Mm.
have any hints over here.
Okay.
The only hint here is not overlook your past experiments and models, because they can give you some understanding of
Hmm.
like data and of the models you had, and how you can reuse it right now. So
Mm.
it's very important to also take it into account, because like maybe your team have developed already 15, 20 such
Hmm.
models, and they have some confidence interval of like parameters. Yeah, why
Yeah.
not use them as your like baseline? uh,
Yeah.
so this kind of three things I would say matter the most.
Okay. Great. Awesome. So pretty much I have to hyperparameters, I think, you mentioned something about metrics, which are the part of the evaluations, right? So
Yeah.
if you have, if, for example, you have no idea if your algorithm is any good and it's like just guessing and hoping for the best. But when it comes to qualitative and quantitative data sets, how would you evaluate them differently? Of course, we know that the qualitative and the quantitative, based on category and numerical, are different. So, because sometimes it feels like quantitative data is deterministic and reliable, and qualitative could be, well, maybe it could be probabilistic. But again, just how would you evaluate both different types of qualitative and quantitative data sets?
Um, I would say it's just everything about metrics, right?
Hmm.
And about like, so there are two different types of metrics. So data metrics, right?
Okay.
Data, I mean models metrics,
Well,
like kind of accuracy, precision,
yeah,
um, mean squared,
yeah.
error rate, weighted mean squared. So a lot of stuff,
Okay.
and your business outcome. So
Mm.
here, important thing is to connect them. So
Okay.
eventually, how you should connect it, it should be via like real scenario A/B testing or whatever you use.
Okay.
But you also can have some proxy that you have on your data set, and that's how you can connect. And some
Okay.
metrics are more correlated with your business one. Some metrics
Okay.
are less. So
Okay.
it depends like on your data set. So
Okay.
just in terms of like quantitative and qualitative, I would
Hmm.
say it's just how you also gonna use it.
Okay.
Because with quantitative, it's like uh, yeah. So let's say that is, there is a price of the car,
Okay.
and you want to predict you want to predict it. So
Okay.
does it matter if you predict it like with 10% error?
Okay.
Maybe yes, maybe no. So you also should think about it. So
Okay.
another one, yeah, it's more like about categories. It's about some stuff like that. But you also should think about what you're going to do with it. So
Mm-hmm.
that's like the key question that you
Mm-hmm.
should ask yourself
Mm-hmm.
before you're building any models.
Yeah.
Uh, and it gonna change the whole of your approach because you may have the same data set,
Mm-hmm.
um, but different, I would say, uh, kind of business use. So we have like a user data, and for user data, you have category, origin,
Yeah.
I don't know, age,
Yeah.
um, how often I don't know, they turned on TV, whatever it can be. And you can
Mhm.
use this data to show ads, for example,
Yeah.
and then you think like, okay, if we want to show ads, so we need to increase our CTR, so our conversion. So we need to increase the probability of a user uh, watch that and click on it. So
Okay.
then let's think about some metrics here. In
Yeah.
other case, for this, we want to uh, share some subscription offers,
Okay.
and for subscription offers, for example, we share it only for people who joined recently, and we want to
Mm-hmm.
promote them to increase their pricing. So
Yeah.
here's the idea: we want to focus on people who are more
Mm-hmm.
likely to to upgrade their tier. So
Yeah.
maybe we should check like I know salaries. Maybe we should check their age, where
Yeah.
they are from, and some other dimensions. So what I'm trying to say that like having one data set, and
Mm-hmm.
one data set can be used in so different ways. Either it's
Wait.
like 1, 2, 4, whatever,
Yeah.
based on your final goal and how you're gonna use it. So that's like the question that's very important to ask. So not only
Mm-hmm.
like, okay, so we have like we want to predict average price car, so we
Mm-hmm.
should use this kind of model, this kind of metric. That's it. But
Yeah.
the question on top of that, how are you gonna use this predicted car? Are you gonna show it like in the ad? Are you gonna share this in some email? So
Mm-hmm.
how it's gonna be used? So that's my like POV on that.
Okay, that's really great. I love the great examples you gave about subscriptions, the subscription examples, the car examples. I really, really love them. That's really good. Um, so of course we cannot talk about, we're talking about machine algorithms, machine learning algorithms, but of course we cannot not talk about large language models because we're in 2025.
Yeah.
Large language models are the order of the day. Absolutely. So, in the era of LLMs, we've seen how data scientists have really gotten so clever, integrating, LLMs with ML's algorithms and, for pretty much rich context. And so here's the question, right? If I gave you all of the GPUs, NVIDIA's GPUs, of course,
Yeah.
um, cores, and basically every cool NVIDIA resources out there, what would you build? And of course, you are allowed to be very ambitious, with your idea. This is pretty much a blank checkbook, like an open checkbook. What would you build? You have literally all of the resources you need.
Mm, okay. No, that's like a good background on that. I have all the resources,
Yeah,
so it helps me.
I
Uh,
see.
yeah, let me think about it. I mean, I'm definitely more leaning towards the build, humanoid robots.
Okay.
Um, and I mean, not like robots we have right now. I mean, some of them are pretty advanced, but it's still like I would say research stage.
Mhm.
Uh, but I love how we right now there are a lot of companies, including Meta, how they're connecting like
Yeah,
math and stuff from LLMs to the real
yeah,
world.
yeah.
Like either via VR, via like humanoid robots and all of it. So that's really awesome. So
Yeah.
I mean, I definitely want some flying cars as well, like in the Fifth Element. In the Fifth Element, I just
Wow.
I don't know why it reminded me of that movie, but yeah, if you watch
Yeah,
it, so
the Fifth
there was some fun.
Element. I remember that movie. Wow, that movie's quite old. Bruce Willis, isn't it?
Yes, yes, it's
Yeah.
1999 or 20, I mean, yeah, it's like whatever, 25 years ago. Yeah,
Hi,
Bruce
what?
Willis.
Yeah.
And so there are like flying cars and stuff.
Yeah.
So I would definitely go into developing something like in between like flying cars and
Okay.
like humanoid robots and how they really can help humanity.
Yeah.
Uh, either like even now like so there are lot of like old and sometimes sick people.
Yeah.
Uh, for example, if we talk even like about Bruce Willis, right?
Yeah.
So he has a disease. But if you have like some, robot, some humanoid that can, help to maintain their life besides like relatives. So
Mm-hmm.
yeah, that's gonna be very awesome. We're not at this stage right now, but
Mm-hmm.
I think we're heading there. And yeah, I'm gonna use all the GPUs for that for there.
Wow. That is definitely worth it. That is
Yeah,
definitely worth
yeah,
it. Okay, that is so good to know. And yes, you were really ambitious with that idea. So I really love that. Okay, so of course, I've had such an amazing time, but of course, I have just one last question for you.
sure.
So, there are currently tons of really young folks, especially now that we are in the AI, era, and so many young folks are kind of like dreaming of joining data science, and maybe one day being as amazing and smart as you are. So they're
Thank
probably,
you.
because I'm like, oh, I want to be like Mark. I want to work for all of these amazing companies. I want to be part of the big tech companies. I want to work for the big tech companies as well. And they are wondering, how do I get into, data science? So, what advice would you give them besides the brace yourself for the endless debugging of ML data and cleaning of data and, cleaning up the missing values and all of that stuff?
Yeah, yeah,
So what advice? And of course, telling them, oh, you have to drink lots of coffee as
yeah.
well. So, what?
Yeah.
Yeah.
I mean, I've been asked this question like a lot of times per day, I would say. Uh, so, first of all, I would say try to be creative. Um,
Okay.
I
Cool.
mean, there can be a lot of stuff you can build right
Okay.
now that you
Mm.
can like share online. You can
Okay.
like publish it. You can like discuss it, etc., etc. Because
Yeah.
when it comes to like pet projects, most people think about like, okay, I mean, I'm just gonna upload like a Kaggle Titanic data set and just build some model, share it, that's it. No, I mean maybe it worked 15 years ago, yeah, but not now.
Not
Um,
now.
yeah, so you should be creative with it. So you should show that you can build something, that you can deliver impact, and that it should be some viable product. And
Yeah.
also, it's like
Yeah.
a part of second advice, but a part of the first one as well. That
Yeah.
you should share it. So don't
Yeah.
hide it. So share
Don't
it
hide.
like on LinkedIn, online, like you just network with people, just say
Right.
about what you've done, what you're looking for, just discuss, etc., etc. Don't be like really, I would say straightforward with that. So like,
Okay.
I mean, you got to some, I don't know, networking data science party, you meet someone and like, yeah, hi, I've done this, please take a look. Yeah, I'd be a bit more like, I would say, as a human being. Yeah, so just discuss
Yeah.
it, and then just share, discuss some, common ground, and etc. etc.
Yeah.
So the second one or the third one depends. Don't forget about foundations because still it's very important.
Mm.
So LLM is not ruling the world. So we still have a lot of models. I've recently posted about it that we're using for recommendation, for regression,
Yeah.
for like animal detection, for a lot of stuff. So we're still using a lot of machine learning models, and it's very important to know these basics.
Yes.
So next one is try to uh, also find internships or reach out to people, for example, like me or like hiring managers, etc., and just say like, yeah, how are you doing? Like, so your team is working on that. I
Yeah.
built this. Maybe we can discuss some opportunities, or
Mhm.
you just can say what's lacking or how can I
Yeah.
mean something like that.
Something
Yeah,
like
because
that.
sometimes it's just a lot of people reached out to me and just sharing their CV and like, could you like do something? So yeah, do yeah. Also, just be human being, and you should be fine. And yeah, I mean, the
Mhm.
last one, it's kind of generic, but don't be too frightened and afraid of
Yeah.
like LLMs and that they're gonna replace you. They're not gonna replace you. The
Mhm.
role will shift a bit, but yeah,
Mhm.
you're not gonna be replaced. So you will be able to find a job.
Yeah.
I can't say in the 10 years because I mean 10 years in
You don't
2025
know
is
what?
like
Yeah, pretty
yeah,
much.
it's a lot. Yeah, so maybe we all like colonize Mars and we'll live there. So who knows? But in terms of like 3 4 years, definitely it's gonna be there.
Oh, yeah, absolutely. Thank you so much, Mark. I've had such an amazing time on this episode, and I know that people who watch this
Likewise.
episode definitely have a nice time. And thank you again for joining us on this episode. We hope that in our future episodes, we could bring you back on, so that, of course, with our technology that is ever changing and with every year we are always surprised with something new coming up. And of course, I was opportune to watch. Actually, I wasn't there live, but I did watch the Meta Developer Conference, and
Yeah,
seeing the amazing things Meta is building with the glasses, the VR glasses. I
yeah,
think that, yeah,
that's cool.
absolutely.
No, that's really cool. Yeah,
Yes, it is. So, I mean, definitely in the future, we would love to bring you back on the Tech Laughs Bytes.
sure.
So, but yeah,
I'd love
thank you.
to be here. Yeah.
Yeah, great. All right. Thank you so much.